All right, so 4.6 is about the last triangle congruency reason. And this is only about right triangles. So right triangles, of course, have a right angle. Let's just talk about some vocabulary of a right triangle because this comes up a few times throughout this course, so not just today. So the longest side of a right triangle is called the hypotenuse. And sometimes people struggle seeing which one is the hypotenuse. And I always, let me erase this so it's a little less confusing. Whenever I do this, the right angle, so here's the right angle. The right angle always points to the hypotenuse. So if that helps you see that, good, use it. If not, try to figure out another way to help you see which one is the hypotenuse. Okay, so the hypotenuse is very important. It has to be the longest side. The other two are not quite as important. They're called legs. It doesn't matter which one. There's not like leg 1, leg 2. They're just called a leg. Okay. So here is the Hypotenuse-Leg Theorem. So this is a way to prove that right triangles are congruent, or triangles are congruent. So if they tell you that the hypotenuse, so the hypotenuse is congruent and a leg is congruent and it's a right triangle, that's all you need. So you can't have a hypotenuse if that isn't a right triangle. So that's only for right triangles, okay? So if you have a hypotenuse is congruent with the other hypotenuse and the leg, one leg is congruent with the other leg, then that's enough to say that they're congruent. Okay? So here's some conditions. Before you use this, make sure that it satisfies these three conditions. First, that both triangles are right triangles. Okay? And then that the triangles have congruent hypotenuses. It's kind of a fun word to say. And then there is one pair of congruent legs. So those are the three things that you must have in order to use the hypotenuse-leg theorem. Okay, so let's do one. So get your proof ready, statements, reasons, your given, and angle RPQ are right angles, and then SP is congruent to QR. Okay, if you need more time, pause it, but I'm going to keep going. So let's talk about what they gave you. So they gave you that they're right angles. Good. So that satisfies this first part of their two right triangles, right? Because if a triangle has a right angle. And then the triangles have congruent hypotenuses. So what did they give you? It says SP and QR. So SP is that one leg right there, or that side right there. Is that a hypotenuse or a leg? We'll look at the right angle. It points at the hypotenuse, remember? So then that is a hypotenuse. Same thing for over here. That's the right angle. It points at the hypotenuse. So then they give us two hypotenuses are congruent. Perfect. So all we have left to prove is that there's a leg congruent. And you see the leg? It is that reflexive side, right? Okay, so let's write it. We can say PR is congruent to PR because of the reflexive property of congruence. Okay, do we have enough? I think we do. We have the right triangles, yes. We have the hypotenuses are congruent, yes. We have one pair of legs is congruent. So then we have enough to finish this off to say triangle PRS, which is just what they have written up here, is congruent to triangle RPQ. And the reason is you can write out hypotenuse leg or you can just write HL. That is perfectly fine. Okay, so let's talk about the next one. Let's go ahead and get your chart ready. And your statements, reasons, and your given. Trying to go fast. Sorry, it's a little sloppy. I give you a lot on this. Let's see what all this stuff means. Gosh, this is a lot. So there's a weird symbol in there. Let's talk about what that means. Okay, pause it if you need to. I'm going to move on. So they give us this weird symbol right here. That is, so this symbol looks like an upside down capital T. That means perpendicular. Okay, and if you remember, perpendicular means 90 degrees. Okay, so just know whenever you see the upside down T, that means perpendicular. Okay, so let's talk about what they give us. So they say that BE, so that line, segment BE bisects AD, right? Okay, so what does that mean? Well, bisects means to split it in half. Okay, and then they tell us that those two segments, so segment AB and BC are perpendicular. Cool, so that means it makes a right angle. And then DE and EC are perpendicular, so that means that makes a right angle. Cool. Okay, so do you see anything else you can write down? Some of you may be tempted to say that these are vertical angles, right? So that means they're congruent. Yes, that is true, but it doesn't really help you on this, because if you did that, because we're trying to use hypotenuse leg. Okay, so let's see. What does this line right here, this is what we're going to have to use. So it says BE bisects AD. So if it bisects the segment AD, means it cuts them into two equal pieces, right? So then we can say, we need to say this in the proof. Oh no, I'm going to run out of room. So we can say AC is congruent to CD, right? Because the definition of segment bisector, because that's what that is. It cut the segment into two equal pieces. All right. Oh, and I see an error I made. You probably already noticed. This is not supposed to be a perpendicular sign. That's supposed to be a congruent sign. Okay. So now, do we have right angle or right triangles? Yes. Which side is this one and this one? Are those legs or hypotenuses? Well, those are legs, and then this and this would be the hypotenuse. So do they give us legs? Yes. Do they give us hypotenuses? Yes. So we have enough to say that triangle ABC is congruent to triangle DEC because of the hypotenuse-leg theorem. Okay. Last one. I know I'm going fast on this. If you need to rewind and watch it over again, please do. Okay, so let's go ahead and go into this one. So I've got, do it really fast. Statements, reasons. CD is congruent to EA. And then AD is the perpendicular bisector of CE. That's our given. Okay, so what do they give us? What is that side CD right here? What is that? Is that a hypotenuse or is that a leg? Well, it looks like that this points at the hypotenuse, so that would be the hypotenuse, right? So we need a leg. All right, so do you see anything else? Let's say they told us that AD is the perpendicular bisector. I'm going to do this. Perpendicular bisector. What do you think perpendicular bisector means? It means it cuts it in two congruent pieces. That's what bisector means, but what does perpendicular mean? And it makes a 90-degree angle. Okay, so, all right. So now, since we know we need to write that, so we need to write that those two angles, or let's say, so even though it's written, it's shown CBD, so let's do angle CBD equals 90 degrees, because the definition of perpendicular bisector, actually let's just go ahead and do the other one because we can. So what would be the other angle that we need to list? Well, that would be angle ABE, right? That one's also 90 degrees because, like I said, it's perpendicular bisector. That's what they do. Okay, so now we know they're right triangles, both of them. Sweet. We know that we have the hypotenuses are congruent. So now we need to know that they are, or we need a leg. But what's the piece that I talked about but I haven't used? The part that I'm referring to is the bisector piece. We haven't done that at all. Like, we haven't said anything about that in our proof. So it says AD is the perpendicular bisector of CE. So AD cuts this CE into two equal pieces. Let's do a different color. So this piece and this piece are congruent because of the definition of a perpendicular bisector, which I guess we could throw on that last line. So we need to write that. So segment CB is congruent to segment BE because of the, let's just do this, definition of perpendicular bisector. Okay, now, do we have that they're right triangles? Yes. Do we have a hypotenuse? Yes. Do we have a leg? Yes. So we have enough to say that triangle CBD is congruent to triangle EBA because of Hypotenuse-Leg Theorem. All right, that is it for this lesson. Thanks for watching. Have a great rest of your day.